So in this video, we will calculate various measures of location. That includes percentiles and different measures of central tendency, the mean, median, mode, and different types of means, the weighted mean, group mean, and geometric mean. So let's just start with this sample data here. It's the sample of microfinance loans available from Kiva to entrepreneurs in Vietnam. And there's like over 4,000 of these that I could have values that I could have gotten. I took a sample of 20, and for the mean, if you recall, you need the sum of the values. Now instead of taking a calculator and adding each value, plugging them in, I'm going to do that, and so my sum is 40,275. I believe there's 20 observations, but just to verify, we can count, and there they are. So I've got an n of 20, and if you recall, for percentile, that is taking n times the percentile, if it's in percent, times 100. And so you are using, you have an I of 6.4. If you recall, using Grosvenor's procedure, we would round that up to 7, and so we would take the 7th observation. Well, we don't want to do that here, and that happens sometimes, so be careful. You've got to make sure you take your data and then sort it. Sort it in ascending order, and so now we can go to the 7th value. 1, 2, 3, 4, 5, 6, 7. So 1475 is our 32nd percentile. And if you recall, percentile is telling us that's the value where 32% of all the observations are at or below that value. 25th and 75th percentiles, those are the first and third quartiles. And so we're looking at the 5th data point. Well, if you recall, again from the notes and Grosvenor, if you have an integer here, you're going to take that integer plus the next integer and take the average. So 1, 2, 3, 4, 5. So we're going to take this 5th value and this 6th value and take the average. One, 2, 3, 4, 5. Make sure I get it right here. Okay, so 1,300, and for the 75th percentile would be the 15th and 16th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 2,375 and 2,500. And we take the average of that. So 2437.5. The median, you could do the same. You could type, you've got the 10th value out of 20, and so you've got 10, the average of the 10th and 11th values. So 3, 6. So I guess I should have done that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1850 and 1925. So hopefully you see how that's done. Okay, so 1887.5, that's the 50th percentile, or the median. The mean is taking the sum here and dividing it by n. And so 2013.75. So you can see the mean is a little bit more than the median. The mode, you can find either way here. You can go through and try to figure out how many there are for each of the values here. Obviously it's a little nicer here with the sorted. You can see that there are 3 values of 1000. There's no other value that comes close to that, so our mode is 1000. Okay. Now there are some Excel functions here. You can use median, and then you can use average for the mean. Okay, and then there's also a mode function here, but you got to be a little careful here. I made a couple data sets here, and if I were to do that for these 2 data sets, so there's one, but you can see that it's bimodal, and it obviously depends on which order, which one it comes to first, essentially. And so the mode can be, from Excel, can be a little iffy, so you have to kind of be careful with that. In fact, I'm not sure I would suggest using it unless you're absolutely sure that there's only a single mode value. So what you could also do with the this information is create a box and whisker. Now I'm not going to create it, but I do want to show you how you would pretty easily come up with the values you need. Well, we've already done the first 3. We've already talked about how to do that, the first quartile, third quartile, and the median. And so then you just take the difference between the third and first quartiles. Okay, so Q3 minus Q1. And then if you recall, to get the whiskers, at the ends of the box and whisker plots, you take the first quartile minus 1.5 times that difference there. And so you get a minus 406.25, and then third quartile plus the same value, so 4143.75. Now, because these are dollar values, this could really be a 0 if you wanted to make it a little more realistic. But anyway, that's how you would calculate the actual box and whisker, the values that you need, as well as the mean, median, mode, and percentiles. There is a command, a couple of commands for percentile. I'm not going to use it. I'll point them out here. There's percentile EXC, INC, and these 2 are essentially the same. For smaller data sets, most people kind of like to use the INC, but it basically has to do with what it does here in computing the rank, the I value. And actually, if we were to use that, it would be different than what we have here, because it tries to interpolate. So if I got a value of 4.2, let's say, it would actually take 20% of the difference here and add it to the 1200. So we'll stay with the Grosvenor procedure. Now, that sample measure, what would be different with population? Well, again, you've got the sum of these values, and you've got the number of observations. Okay, and you've got median, mean, and mode. We won't worry about the percentile in this case. So does the median change in terms of how we calculate it? Of course not. You've got your sorted data here. We're taking the 0.5 times the number of observations, 8. Okay, and so we get a value of 4. So 1, 2, 3, 4. So we're going to take the average of the 4th and 5th value. Well, that works out nice. Don't even have to average that. It's 1500 since there's 2 of them there. The mean is 17100 divided by 8. So there's your mean. And the mode is actually bimodal, isn't it? 1000 and 1500. Okay, so how we calculate these values really didn't make any difference. It would be the same for percentiles. What's different here are the notations. The population mean is mu. The sample mean is x with a bar over it. I can't do that in Excel that I know of, so I just type out x bar. Okay. The other is here, n. This is a small n for sample, large N for population. So that's what you mainly have to make sure you distinguish. Let's move now to weighted mean. If you recall from the weighted mean, and you know, these videos assume that you have looked at the notes involving the topic that we're dealing with. So you really should do that first before you watch videos. And what we do here is we have unit price of say some lumber, a certain type of lumber, and we have the number of units that are needed. And so here we needed 2 of this type of lumber, 8, 4, 40. Actually, let's move that to, let's make that kind of small here. So 4 and 40. So let's say this is 2x4s, and this maybe are long, some type of beam or something like that. So we need a lot of 2x4s, a few beams, and so on. But what's the average cost per unit of lumber used in this project? So we can't just take the mean of these values here. That would be $33.6. So is that really the average cost? Well, if we took 33.6 times the sum of all these, that actually wouldn't be the total cost. So we need to look at a weighted mean. So what we do is we multiply the unit price times the number of units, because this assumes that we have the same number of units per type of lumber, and that's not the case. Okay, and so we need the sum of the number of units. That's going to be our denominator, and we need the sum of the unit price times the number of units. So what we're going to do then is take $870 divided by 58. Okay, and so now the average price is 15. Okay, so that is a weighted mean. An example of a weighted mean that you're very familiar with probably is the course grades. Some people use point system, but others use each exam is worth a certain percent and so forth. So you use the weighted mean to figure out what your course grade is. Now, grouped mean is, if you know how to do a weighted mean, you know how to do a group mean. The only issue is, what do I use for a value here, where I multiply it by the weight? My weight will be my frequency. Well, the best thing that we can really do is use an estimate. So here would be just the midpoint of our class. So 12, 16, 20, 24, and 28. Okay, so now it's taking the midpoint times the frequency, and then we sum our frequencies. We sum our midpoints times the frequencies. Okay, so the group mean then would be 988 divided by 50. So we would say that our estimated mean number of ounces for whatever this is 19.76 based on the information that we have, these frequencies that we have. Okay. Now I have another one here just because I want to show you that now number of people, you can't go all the way up to 200. You have these are integers, and so you need to be careful. You wouldn't use 150 like we basically did here, right in between these values. So just take well, basically the average. Let's just do it that way. Of these two values. Okay, so now those are our midpoints, and so now we just multiply the midpoint times the frequency. So now it's just like we did before. Okay, and then sum. And sum. And the numerator divided by the denominator. So 309.5 is our estimated mean based on this distribution. So 309.5 people would be our average, our estimated average. Modal class, all I want for that is what's the highest frequency. So in this case, 14 to less than 18. In this case, it would be 300 to 399. That's all you have to do for that. So just whatever is the highest frequency. We're not going to try to estimate what a mode is or median. There are ways to do that, but we won't do that for this class. And then finally, the geometric mean. Many of you are business majors, so you might be interested in rates of return. And let's just say we have an investment value starts at 200, and you want to see what your rate of return is here. So obviously we take this value minus the previous value and divide by the previous value. Okay, and you can put that in percent if you want. I'm going to leave it alone. Okay, and so we had a 0.05 or 5% increase from year 1 to year 2, no increase, and then it decreased, and then had a decent increase the next 2 years. Okay, well, I could do a arithmetic mean of that rate of return. That's fine. Again, I'm going to cheat here just in the interest of time. You're not allowed to do that, but you certainly, what you should do is use it sometimes for to check your answers. Okay, so the arithmetic rate of return over those 5 years is 0.0471, so 4.71%. However, if you take that number, if you were to start at 200 and multiply that times a factor of 1.0471, do that 5 times, you should equal 250. Well, that's not going to happen if you do it here because of the compounding that's going on. So to get the actual compounded annual rate of return, we need the geometric mean of the adjustment factors. And the way to get the adjustment factor is either add 1 to these rates of return, if they're not in percent, just add 1 to those, so 1.05, 1, 0.0, 1 minus 0.0238, so 0.9762, I guess. So you could do it that way, or another trick is to just take this number divided by this number. Okay. So now you have your adjustment factors. So if you were to multiply 200 times 1.05, you'd get 210 times 1, 210 times 0.976, 205, and so on. So now what we want is the product of these values here. And there is this we can do along with the sum. I'm okay with that's using product if you're ever have you use Excel for something like what I'm doing, but most of the time it'll probably be something on paper that you'll be doing with your calculator. There will be a few Excel uses, but so this is the product. So the geometric mean then is this value to the nth root. Well, 1 divided by 1, 2, 3, 4, 5. There's 5 observations. Okay, so there's the geometric mean. That's not the rate of return. The rate of return would be this geometric mean minus 1. Okay, and so you now have a little bit different value. This is the actual rate of return. Because of the compounding that's going on, you get to 250 with a little bit less rate of return because of that compounding that's going on. One last way of calculating geometric mean is to take the end value. So say we had an investment worth $2 million. Divide it by the beginning investment value. Take the nth root of that. So there are 14 periods. If you go from 2000 to 2013, you got 14 periods here. So 1 divided by 14, and then we want to get it out of the adjustment factor, so then we're going to subtract 1. Okay, and there's our compounded rate of return, our annual rate of return. Okay, so that's the various ways of calculating measures of central tendency. If you have any questions, let me know. If anything needs clarified, either in the notes that are provided or in this video, just email me, and I'll be happy to respond. Till next time.